okay, so now that we're recording, we're on chapter 4 now, and the question is, when it says by graphing, do I have to actually graph? So let's pull the test, and I'm going to show a question like that.
Because then if I could use Desmos, how would I use,
I will show you. So solve each system using elimination, using graphing. So here we go. Solve each system using graphing. So the first thing I want to do is get these into slope-intercept form so that graphing them is easier. So I'm going to grab this and drag it over to Smart. Give me just a second. Okay, so if I split these up, look at my 2x plus 3y less than or equal to 6, and then I have 3x plus 2y less than or equal to 6. Ignoring those. Slope-intercept form, I have to either start by dividing or start by moving. I like to start by moving. I might as well show my work. I subtract 2x from both sides. That gets my y term to be the only thing on the left side. I then, to get the y by itself, or just one y, divide everything by 3. Now I'm going to flip my order around here. I'm going to put my x value first. So it'll be negative 2/3 x, then plus 2, because 6 divided by 3 gave me 2. So this is my one inequality that I need to graph. Then I need to manipulate my other inequality. So I'm going to move again first. That gives me 2y less than, I'm just going to go ahead and write my x term first. I then divide by 2 everywhere. That gives me y less than or equal negative 3 halves x plus 6. These pens, they're jumping today.
Wait, wouldn't you divide the 6 by 2?
Yeah! Good catch. You know, as I walked away, I was like, did I do everything? That was not on purpose. That was by accident.
So when you're solving it, do you just treat the equality sign like an equal sign?
No. So, y is less than or...
Not when you're graphing it, just when you're solving it.
What do you mean?
Like when...
No, still no, because if you divide by a negative,
okay,
you do have to flip it around. So you can't like think of it as an equals. You got to think of it as the
okay.
inequality symbol. So everyone is aware, correct, that if in my division up here, if either of the values that I divided by were negative, that would flip the inequality symbol. So the reason it stays facing the same direction is I divided by a positive. But if I divided by a negative, this would flip direction because we're doing an opposite, like an operation with an opposite.
So with these, you just solve each one separately?
And then we're going to graph them together. So, and you could graph them on paper. This would not be that hard to graph. You have your y-intercept and you have your slope. But if I want to do it through Desmos, make this easy.
Like some kind of a 90s business logo or something.
What, Desmos? Oh, this?
No, that just...
So I would say y is, what do we have? Less than or equal to negative 2/3 x. What did that do? It's weird. Something in the formatting just got goofed up. There we go. So notice it's now going to shade the range of my solutions, and because it's less than or equal, the line is solid because it has the or equal, and because it's less than, it's everything below it. So then when I put my next function up here, y is also less than or equal to, but now it's negative 3 halves x plus 3. So the region that is shaded by both of them is the final solution. So like so to turn in your assessment, if we're talking about practice work, you can just do it in a calculator or whatever. But Jocelyn, for your question about the assessment, you do want to make a small drawn graph so that you can show which area does both shade. So you could even make it a 5 by 5 graph. Your graph could be just this region, and you could just show this line, that line. I normally shade one with vertical lines and the other with horizontal lines, so I can see that the area that has both horizontal and vertical lines, that's my solution area. So a point like 0, 0 is in the solution, but negative 2, 4 is not in the solution because it's not shaded under both. Does that make sense? So if it asked for a solution point, anything in this region. Cool.
So what? Because that's just for.
That's for solve by graphing. If it says solve by graphing,
but that's
you're graphing.
for the later ones, which these are on equal signs. And equal
Yeah.
signs are what's zero.
Equals are easier. Yep.
Can I go to the library?
Oh yeah. If you feel good. Other chapter 4 stuff. This is the G form of the test, so if you have any specific test questions. How do we know if it has one solution, no solution, or infinitely many? So if let's just review this really quick. If I'm asked this question, come on. Shift V and Alt V are very different from each other.
Wait, alt.
Or, yeah. Sorry, Alt is for print screen. So, if I want there to be one solution, what shows me that it has one solution?
It has a different slope.
So, different slopes. Yeah.
If
You can give me
it'll
whatever
have
you want. I'm
none.
just writing these.
it'll have none if I'm sorry, I'm not very good at this.
It's okay. So a solution point is where one line hits the other line, right? So think about when would there be no intersection between lines?
They were parallel and like opposite.
Same slope with Megan? Yeah, see, she raises her hand. With different intercepts. I'll go ahead and write that out. So what about infinitely many? When would every single point be a solution point? Mr. Walker, since you're awake?
Yeah, when they're the same line.
When they are the same line. Literally same line. Same slope, same y-intercept, same everything. So that is how we can determine one, none, or infinitely many. Once I get it into slope-intercept, I just use that to determine. Other questions from Z-test? How do we substitute? Solve by substitution. What's like, who can, in like 20 seconds or less, explain that process? Caleb?
Solve for one variable, then plug that variable back into an equation, and
Yep.
then just solve it.
Choose either equation. I always choose the one that looks easier. Solve for one of the variables, plug it back into the other equation. I've seen some people plug it back into the same one, and they end up in like an infinite loop. You just get the same thing. Elimination. Who can explain how we solve by elimination? Bounce over here.
Like subtract or add the one equation to the other one.
Yeah, I either add or subtract the equations together depending on what I'm trying to eliminate. So like in 10, I could do either. If I subtracted them, I'd eliminate the x. If I add them, I'll eliminate the y. So if I add these equations together, then I would get 2x, the y's cancel, equal 10, and then I get x equals 5, and then I can plug x into either of these to figure out what the y equals. So that easy.
Could you go back to elimination, substitution? I don't quite understand.
So, thank you for asking. Substitution. I'm going to grab some of these and put them over in the Smart Notebook. So what I use Alt for, if you hold Alt and then hit print screen, it'll print screen or like take a picture of whatever you're currently like selected, and then I just copy and drop it.
There's also the clip.
Yeah, some PDFs are locked and it won't let you clip. Like it's really weird settings. That's the best like get around I've ever found. So substitution. This bottom equation looks much easier to isolate a variable than this top equation. Quite honestly, I don't want to mess with that equation. So to isolate a variable here, I add y to both sides, and I find out that x is equal to y minus 1. Now that I know what x is, and since I used this equation, I can't use that equation again. I take this and I plug it into the other equation. So what we now say is 3, well, not x anymore. Everywhere I see x, it's now y minus 1 because I know what x is in quotation. Because I don't really know what it is, but I have an expression to represent it. So then minus 5y equals the negative 1. I distribute to start simplifying. 3y minus 3 minus 5y equals negative 1. I combine my like terms. So 3y minus 5y get me negative 2y. I still have that minus 3. I'm going to add 3 to both sides to combine those variables, or sorry, to combine those constants. I get negative 2y equals 2.
Oh, and okay.
Divide to isolate. Now we're still not done. So y equals negative 1.
And then you just
So
solve it.
I really know what y is now. Since I really know what y is,
Okay, it's
I take it and I use it to figure out what x is. So now I say, well, x, well, instead of y is negative 1. So instead of y, I say negative 1 minus 1. X is negative 2. So my solution point is negative 2, negative 1. The x value and the y values that I have found.
And then with elimination, you just eliminate like terms.
Yeah. So you're just trying to combine them to cancel
Even if
one of them
they're-
out.
For
Now-
instance, if they're both positive, can you do that?
Yeah, so you can do subtraction then. Now the difficult part of that happens when, let's do an example like 12. Can I just straight up add or subtract these two together and cancel out a variable? No, because I don't have any variable terms that have the same value, right? I have like 3 or 2 or 1. Ooh, so I can multiply. So what I'm going to do is say, well, what variable do I want to cancel out? It doesn't really matter. Since I see that this is positive and this is negative, I'm just going to go ahead and say, let's cancel out the y. So I'm going to take this whole function, say, what would I do with it to get a matching value or the opposite value of one of those variables? If I double it, my y's will match. So this becomes 2x plus 2y equals 14. That can be combined with 3x minus 2y, which equals 11. I'm going to combine that through adding the two functions together. So I get 5x. These cancel with each other, equals 25. To solve for x, divide by 5. My x value must equal 5. Now plug that back in to one of your equations. Well, if x equals 5, I can bring it back over here to this original equation and just say 5 plus y will equal 7. What's y? 2. So my solution point is 5, 2.
That's elimination, right?
Yes. So that is elimination with the slight variance that we have to multiply first. So then there's really tough ones, which is why I gave you the K form of the test. They have some of the easier forms of the questions. There's really tough ones like 13. I'd have to multiply both of my functions to get them to match up with variable values. So if I was dealing with 13, I could multiply, let's say I'm trying to cancel out my x's. You could multiply your top function by 8 and your bottom function by 7, and then your x values would match. And then you could subtract one from the other. And I want to see more of those or other questions from chapter 4, Chaitna?
Can I go to the library?
Yeah.
And do you need the signature?
Yeah, if you have it, yeah, I'll take it, the syllabus sign. Yeah, I need these. I know I only see you guys once a week, but I need these back at some point. So I'll really start to bug you next week if you still don't have it. Any other? Yeah.
Kind of one question I have is with 13, it's kind of weird how I don't really know how you would set up this.
Let me see if I can find a similar problem. Booted me out.